Hey everybody, this is Trey with BlackFalconElectronics.com, and in this video I will be showing you part 2 of Project Aurora. So of course we're going to have to go back to the Black Falcon Electronics mission board so we can look at more systems that will be used for Project Aurora or the Arduino control solar panel project. So there are going to be 3 subsystems discussed in this video today. So the first one will be the AARCS unit, or the Automated Annual Residency Control System. You have here your water distribution system, and you have your water purity system. So I have discussed Project AARCS before. Project AARCS is basically going to be an automated enclosure that will monitor the heat, humidity, as well as the ventilation for each of the animals. So that consists of several items. Radio AC12 for wireless communication, requires your temperature, humidity sensor. It requires a sensor for the heat pad, a buzzer, a heat lamp, and a heat lamp relay, and a button and potentiometer. And of course, all this is going to be programmed so that it manages itself. So that is the AARCS system. Now, the 2 more interesting subsystems that I will have is the water purity system and the water distribution system. So let's go ahead and focus on the water distribution system. So the water distribution system, as the name implies, will be how water gets distributed from the main unit and gets distributed to whatever systems need water. Now, it could be the system needing water and enclosure needing water for the purposes of drinking, or could also be, in case of Avery and Suki, my 2 water snakes, it could be for their habitat, as part of their habitat, so they can swim around, get some fish and whatnot. Because the idea for Avery and Suki is for fish to be inside of their container so that they can eat at their leisure. So because of that, I will need a constant circulation of water from the main unit and down to their enclosure, and it gets filtered and whatnot. But that subsystem specifically for them will be discussed at a later time. For now, you have several items for the water distribution system. One is here. This is your HC12. This is your radio. So this can send and receive signals, and based upon those signals, I can code it so that the system does whatever I need it to do. Now, the system itself is going to have a pump that goes up and gets capped. So this cap allows there to be a building of pressure so that the water will have enough force to go through to these individual lines here that you see that go to the separate enclosures. Now, to ensure that the pressure gets built to further assist it, now we're going to have a check valve here, and a check valve allows water to go in one direction but stops it from going the other. And that allows there to be a buildup of pressure in this specific area so that, again, the water can be moved to the specific enclosures. Now, each of these pipes that go to the separate enclosures is going to have a solenoid valve. Now, a solenoid valve is a lot like a check valve. Water can go one way but not the other, typically, at least not easily. Another thing though is that it's electrically operated. So if I wanted water to go to just this topmost pipe, then I would ensure that these 2 are off so that all the water goes here. But if I wanted the second one, the middle pipe, to activate, I would use an electrical signal, and that would open this solenoid up and allow water to go through it. So all it is a valve. You can open or close the valve depending on if you apply electricity. Now you have 12 volt, 24 volts. Obviously I'm going to go for the 12 volts because it's a lot more convenient to activate and deactivate the solenoids. Now most likely what I'm going to be doing is using an N-channel resistor. Not in-channel resistor, an in-channel transistor to operate it. But I'll have to check to make sure that it does not get too hot when operating, and see at what point does the temperature of the in-channel resistor gets too high for me to operate the solenoid in a safe manner. Now, with all this pressure being built up here, there needs to be a way to remove that pressure. So I'm going to split where this check valve is, right above it. I'm going to have the pipe split so that I can put another solenoid that'll be closed, and I can have all the excess water run off back into the main unit. Now what that allows is for me to relieve the pressure and not have stagnant water just sitting there for days or weeks on end, depending on how I decide to engineer the system. Now, another portion is that I will need to have a filter. Now, even though, the water that I put in here is going to be clean, you still want to make sure that you have a water purity system that allows you to continuously ensure that there are no bacteria, fungus, viruses, or what have you that are breeding inside the main reservoir to then be distributed to all these different enclosures managed by the automated animal residency control system. So that is where we get into the water purity system. But one last thing for this HC12, now it will receive code from every AARCS unit. So if an AARC unit says, hey, I need water, then it sends that signal from the AARCS HC12 to the water distribution system HC12. It interprets that code, sees what enclosure needs it, and then what it will do is it'll activate that specific solenoid, and then it will run it will go ahead and run everything. So that is how the water distribution system is going to work. Next, let's go ahead and go into the water purity system. Now, the water distribution system is going to be this reservoir that you see here, and this is going to go out, have a pipe that goes out as you saw in the previous section. But the main reservoir is going to be in another enclosure. And the reason why it needs to be in this large enclosure is because it will have a UVC light as well as a filter. Now, the UVC light has the potential of being very dangerous. Now, UVC light is a special type of radiation that is emitted by the sun, but it gets captured in our atmosphere. It doesn't penetrate our atmosphere. It hits our atmosphere, but then it gets filtered out. UVC light is capable of destroying DNA. Now, conceivably, from my research, it is possible to get cancer if you constantly expose yourself to UVC light, because that radiation damages your cells, and it can actively burn your skin. If you look at some of the videos that are going around, you can actually burn yourself, hurt your eyes, and it can lead to blindness with significant enough exposure. Now, acute exposure, which acute means small term, it may or may not cause a lot of damage. But if it's chronic exposure, meaning over a long period of time, then yes, you run the risk of perhaps going blind, which is very unfortunate. Now, for safety, what I'm going to use is a reed switch on this outer container. So what a reed switch does is you have a magnet, and then that magnet, that permanent magnet, either allows or disallows electricity to flow through the other side, because there are two parts of it. Now, depending on the type you have, you might have normally open or normally closed reed switches. If it's normally open, then that means when you apply the magnet, then nothing happens because it's an open circuit. When you remove it, then it closes the circuit, and then you can detect that with the Arduino, and then from there you can have something happen. So what will happen in this specific instance is have a reed switch that's connected to the Arduino. As soon as you begin taking off the top of the enclosure, then the Arduino detects it and automatically disconnects this UVC light. It turns off. You can open it, do what you need to do. As soon as you close it back, then it'll reactivate if it was doing a sterilization cycle. And what I'm thinking about is having two of them. So one at the on one side, one half, and another reed switch on the other half, to make sure that they both have to be in place. And if they're not both in place, then you have a problem, because that will stop me from, let's say I took a top off and I leaned it against it. If it's just one reed switch and I lean it against that side that the reed switch is on, it could activate, and then I have to worry about acute or chronic exposure. So to stop that, have it on two sides, one in the front, one in the back, but they're on opposite sides to ensure safety. Now, this filter that I have here, the point of that is I have a filter, a charcoal filter, activated carbon charcoal filter, and what that does is the UVC light kills everything, but then the filter takes it all out, so that when it's time to be distributed, you can have pure clean water distributed throughout the system. Now, is it going to be perfectly clean? Of course not. You're always going to have a little bit of variance, but it significantly lessens the likelihood of there being a fungal outbreak or a viral outbreak or a bacterial outbreak while this water is being in storage, because it could be in storage for a long period of time. It could be. Now, here at the bottom, I have a diagram of how the reed switch could work if, when the reed switch is closed, you get a high signal. So if you get a high signal, that means the magnet is allowing the electricity to flow when it's closed, when the door is closed, or if you, in this situation, in the context of this water distribution system for the water purity subsystem, have it there. And then as soon as it opens, I show how connecting it to a relay, how it can disconnect and reconnect the electricity that goes from the reed switch to activate a relay that relays high voltage, high amp, which is connected to the UVC lamp, which is connected to electrical outlet. So that is the last part of the water purity system. It's just to make sure that whatever may be in the water gets killed by the UVC light, gets filtered by the activated carbon filter, and then gets distributed via the water distribution system. The water distribution system then will activate depending on the AARCS unit, that automated animal residency control system, so that water can be distributed throughout my enclosures. And that's the video, guys. Alrighty guys, so thank you for watching this video. Again, this is Trey with blackfalconelectronics.com. Please like, share, subscribe, comment, share with your friends, different communities, Facebook, Reddit, whatever community you're part of, so I can get good feedback for this video. If you have anything you would like to say, or if you would like to interact with me, of course, put in the comment section below, or you can contact me at blackfalconelectronics.com. I have a contact me form that you can fill out, and then we can converse from there if you give me an email address. So thank you guys for watching the video. I'll see you guys in the next one, and have a very blessed day. And please make sure you wash your hands. Thanks.